We're going to take a look at solving absolute value equations and inequalities. The only way that you can get rid of an absolute value bars, and this is only whenever there's an x inside of the absolute value bars, the only way that you can get rid of these absolute value bars is to split the equation. When you split the equation, you never change whatever's inside the absolute value bar. So we'll put x minus 3. And then the first time you're going to put it equal to a positive 5. It should look exactly like the original equation, just without the absolute value bars. And the second time, we still do not change anything that's inside the absolute value bars, but we do change the 5 to a negative 5. So you have x minus 3 is set equal to a positive 5, and x minus 3 is set equal to a negative 5. This is the only way that you can get rid of those absolute value bars. Now, once you've done that, you simply got to solve for x. So we're going to get x by itself. Add 3 to both sides. These cancel. And x is equal to 8. And then over here, we'll add 3 to both sides. And x is equal to a negative 2. You should, for the most part, have 2 answers every single time whenever you do an absolute value equation. All right, taking a look at an absolute value inequality. Now, the same rules are going to apply. We're still going to split this in order to get rid of the absolute value bars. We never change whatever's inside the absolute value bars, so we're going to have x plus 5 is less than 7. And the first time, it should always look exactly like your problem, just without those absolute value bars. Now, the second time is where the tricky part comes in, because you're going to set this x plus 5 again, but whenever you turn this into a negative 7, we have to flip our inequality symbol to where it's a greater than symbol now, and then negative 7. So we're going to solve both of these. We're going to subtract 5 from both sides. And we get x is less than 7. Subtract 5 from both sides. And we get x is greater than negative 12. And then there's actually one last thing we have to do. Our original symbol was a less than symbol. And less than is less than. And it goes with the word and. And means that we have to write these together, make it one big conjunction. So what we're going to do is we're going to take our smallest one. Now, the one that's the smallest should be the one that has a greater than symbol. We're going to take that one and we're going to flip it. And this gives me negative 12 is less than x. And then we're going to take the other one, and we've already got the x there, so we're just going to move the less than 7 right next to it. And this is our final answer right there. So anytime that we have absolute value inequalities, if it's a less than symbol, it's less than, and we have to write this together. Let's take a look at, now this one looks like a less than, but the absolute value bars are on the right hand side. Usually we like for them to be on the left hand side. So what we're going to do is we're going to flip this entire thing and make this look like it usually does. Now, in order to flip this, I have to make this a greater than symbol now in 3. So we took the entire problem and we flipped the entire thing. We don't just flip these two sides right here. We also have to flip the inequality symbol as well. So now that we've done that, we've got an absolute value with a greater than symbol. Okay, greater than, we actually say greater. And greater means that we can actually leave this answer apart. And so we're still going to split this just like normal. And when we split this, we have negative 2x. Remember, you do not change anything inside the absolute value bars. Is greater than 3. So it looks just like the first equation, just without the absolute value bars. Now when we write this the second time, we have negative 2x minus 4. So still don't change anything. And then here's where we flip this to a less than symbol because we're changing it to a negative 3. After you've done that, now we just got to solve for x. So we're going to add 4 to both sides. We have negative 2x is greater than 7. Divide by negative 2. And any time that you divide by a negative, we have to flip this inequality symbol and get x is less than negative 7 over 2. And then over here, we add 4 to both sides. And we get negative 2x is less than 1. Divide by negative 2 to both sides. And x is less than, I divided by a negative, which means I have to flip my inequality symbol. So this now becomes greater than negative 1/2. And in this case, we will have two separate answers because of the fact that this is a greater, and if we were to graph this, my arrows would be going apart, so we can go ahead and leave our answers apart.